Okay, let's do some more derivative examples. Now in this example, the first thing I like to do whenever I see something like this is just rewrite it, changing any roots to fractional exponents and bringing up any fractions like this to negative exponents. Then I will take the derivative. So here we have 7 times 4 x cubed minus 8 times a half x to the negative 1/2 plus 3 times negative 2 x to the negative 3 plus 0. Simplify, we get 28 x cubed minus 4 over root x minus 6 over x cubed. Now in this example, we're going to be using the chain rule. Now this is a common one where people want to do a product rule, but because of this minus sign, there is no product. The only product is 4 times the square root. And the 4 doesn't have a variable, so we don't need to use the product rule. Now just like the last example, we're going to rewrite it, putting the root into fractional form. Now we take the derivative of 3x squared, which is just 6x. Then we do the chain rule for the second part, so 4 times a half. Rewrite the inside, subtract 1 from the exponent, and then the derivative of the inside. Simplify, we end up with 4 times a half is 2, times 2 is 4, and then the root in the denominator. Here's another example using the chain rule. Now yes, you could use the quotient rule, but if you look at the numerator, the 9, the derivative of 9 is just 0. So it's not worth doing the quotient rule for. It's much easier just to do a change to make this 3x plus 7 to the negative 1, and then just use your chain rule. We have 9 times negative 1, 3x plus 7, subtract 1 from our exponent, derivative of the inside, and then we simplify, we end up with negative 27 over 3x plus 7 squared. All right, this example is a product rule. Now there's a couple different orders you can do the product rule in. So I'm going to take the derivative of the first, using the chain rule, rewrite the second, plus the first, derivative of the second. Now to simplify, and this would be your final answer. Now yes, you can factor this and simplify this further, but I don't expect you to go this far, but if you wish to see it, we can take a 6, 2t plus 1 cubed, t squared minus 3 to the 4th out of both, leaving us with 2 t squared minus 3 plus 5t, 2t plus 1. And then we can simplify what's inside the square brackets. Now again, you can do this, but I am perfectly okay if you stop here. In this example, we're going to do the quotient rule. We're going to do the derivative of the top times the bottom minus the top derivative of the bottom all over the bottom squared. Now we can simplify. And then we can simplify further. There's a couple different ways you can look at it. You could factor 4x minus 3 squared out of the top terms and then divide that out, or just realize that you can take out 2 copies from each. So this will leave us with which we can then multiply out the top. Collect like terms. Giving us our final answer.